All right, welcome back. In this video, we're going to pick up where we left off in the last video for section 7.1. And we're going to cover example 3 here, where it's called eliminating the parameter. And so sometimes we need to be able to take our two parametric equations, x of t and y of t, and we need to be able to rewrite them back in terms of x and y, or y as a function of x, or x as a function of y. And so that's what we're going to do in example 3. The directions say eliminate the parameter t for each of the plane curves described by the following parametric equations and describe the resulting graph. So what the idea here, if we're going to do this, is you want to take a look at your two equations and you want to say, okay, which one of these two equations is going to be easier to solve for t? Because you always have to start that way. You need to solve one of them for t. And so go ahead and think about that for a second. If you look at x of t and y of t, which one of these equations is easier to solve for t? Well, hopefully you said that the second equation is easier to solve, because the first equation is quadratic. You have t squared and t. That's going to be really difficult to get t by itself. However, the first one, if we take y of t, so y equals 2t minus 1, I could add t, right? Add 1 to both sides. That gives you y plus 1 is equal to 2t. And then you could divide both sides by 2. So if you divide both sides by 2, you get t equals y plus 1 over 2. And that's not super ideal because it's still kind of an ugly expression. But remember, the goal here, if we're trying to get something in terms of just x and y, is that we want to eliminate the parameter. In other words, we want to eliminate t. Sorry about that. We want to eliminate the parameter t. So if we're trying to eliminate t, what we need to do is we need to take, then, once you've solved for t in one of the equations, you need to take and substitute that in for t in the second equation. So let's go ahead and do that. If we take our equation x equals t squared plus t, and we substitute y plus 1 over 2 there, we get, first of all, x equals y plus 1 over 2 squared plus y plus 1 over 2, which, you could, I suppose, stop there, but it sure would be nice to get this into something that looks a little bit better, something that we can more recognize, because right now I can't really recognize what type of equation this is. I mean, I might have the idea that it's quadratic because you can see a squared here and you see y, so it looks like we're going to for sure have a y squared. But let's go ahead and see if we can simplify this just a bit. So if I expand this first part, what are we going to get? We're going to get, if I square the first part, we're going to get on the numerator, we're going to get y squared plus y, so plus 2y plus 1. If you don't believe me, go ahead and do that on the side. Then if you square the denominator, 2 squared is 4. And we have plus y plus 1 over 2. And it would be nice if we could add these two fractions. In order to do that, we're going to need a common denominator, so we could multiply the second term by 2. So that's going to help things out. If we do that, we're going to have x equals y squared plus 2y plus, that doesn't look very good, let me rewrite that, plus 2y plus 1 over 4 plus, and then distribute that 2, plus 2y plus 2 over 4. And now we can go ahead and combine the two fractions. And when we do that, we get x equals, well, what do we have? We have y squared. We have 2y and 2y makes 4y. And 1 plus 2 equals 3 over 4. This is looking a lot more quadratic, isn't it? Okay. And then we can go ahead and split up this fraction. So we get x equals 1/4 y squared, or y squared over 4, plus 4y over 4. Actually, why don't we, just so it's not confusing, let's go ahead and write this in 2 steps. So y squared over 4 plus 4y over 4 plus 3 over 4. And we can go ahead and simplify that, and it gives us x equals 1/4 y squared plus y plus 3/4. And this is definitely quadratic in nature, but it's an x equals y squared instead of a y equals x squared. So this is what we call a horizontal, or a side, I would call it maybe a sideways parabola, right? Sideways parabola. Okay, so now that we have gone ahead and eliminated the parameter, let's go ahead and look and see what this does look like in Desmos. We think it is going to be a parabola, but if we go to Desmos, we can go ahead and enter x equals 1/4 times y squared plus y plus 3/4. And so it is, in fact, a sideways parabola, but it's not the whole curve, right? Let's go back to our graph. It says that the t was in terms of, or t went from the bounds -2 to 1. So when t equals -2, for example, we know that x is going to be -2 squared plus -2, which is 2. We know that y is going to be 2 times -2 minus 1, which is -5. So that t equals 2 is really the point 2, -5, right? And then we could also look at t equals 1. There's the other end of the bounds. When t equals 1, we can see that x is equal to 2. And of course, y would be equal to 1. So we have the point 2, 1, which means if you look at the y values, y is going from -5 to 1. And so we can kind of limit this graph. We can say, in curly brackets, we can say from -5 to 1. And so it's not the whole graph. It's from -5 to 1. And so that's how we graph it, x as a function of y. I also want to show you, though, how to use Desmos to graph just parametric equations in their standard form. Remember, x was equal to t squared plus t, and y was equal to 2t minus 1. So how does that look? All right, so what we do is we graph it as a point. So we, like an ordered pair, we make our parentheses, and x, again, was equal to t squared plus t, and then we go comma, what y was equal to. Y was equal to 2t minus 1. And then we need to specify our values of, oh, I can see here I had a typo. That should be t squared plus t. And then notice it automatically puts the bounds in from 0 to 1, but of course, in our problem, it was from -2 to 1. And so now you can see the purple curve completely overshadowed the green curve. It's the exact same thing. I can go ahead and delete my green curve, and there's my parametric curve. So that's how you do it in Desmos. Let me also show you actually how you would do that in a graphing calculator. So let me pull up my graphing calculator here. I'm going to turn it on, go to y equals, and you can see normally we're used to having y equals form, but we can change our mode. If you hit the mode button, and you can go ahead and go down to and change this from function mode to PAR, parametric mode. So press enter and highlight that, and then go back to y equals, and you can see that it's now changed how we enter functions in. So we can go x is equal to t squared plus t. And notice that when you hit this button that we normally use for x when you're in parametric mode, it puts t's in instead. And then press enter, and then y was equal to 2t minus 1. And we can go ahead and now hit graph. The window is not great. Let me go ahead and start by changing my zoom. I'm going to hit zoom and go to 6 for my standard window. And you'll see it doesn't give us that whole parabola. If I go to window, hit the window button, you'll notice that we can now change the values for which t will range through. So remember, ours go from -2 to 1. And when we hit graph, we should see the same graph that we had in Desmos, which we do. And you can also go to the table, and you'll see some tables of values. So we're at -2. You can see x is 2, y is -5. We already calculated that. When t was equal to 1, we got x equals 2 and y equals 1. And so there's a lot of things you can actually do with your graphing calculator to also help you with parametric equations. And that's going to go ahead and do it for this video. And also that will do it for section 7.1. So let me know if you have any questions. Thank you.